giving a presentation with my good bud, Todd Hanson, who's there. Come on, Todd. So welcome Todd to the stage. Todd's the senior mechanical engineer at Infinity Mechanical, which is in Deep here, and he's a wizard with CAD. He's nuts. Where's your hat? You need a hat to be a wizard. Okay, so who's seen the Embark sculpture on Washington Street? Okay, yeah, you like it? Good. I like it too. It looks like this, except for it's a lot bigger. This is the maquette that we did very early on. Wow, so that's what I'm talking about, Matt. Look at you on the ball there. Okay, so this is what it looks like. The maquette. There's no engineering really in this. It doesn't move around. It's static. The actual piece is kinetic. But this gives you an idea of what it looks like if it was in a fairly turbulent storm, which it has experienced multiple times so far. So our conversation today is going to be on how this was conceived and then how it was finally fabricated and installed. Because I'm an artist. I do fabricated sculpture. I also do paintings. But making this piece, there's no way I could have done it on my own. This was a huge collaborative effort crossing multiple disciplines on the STEAM platform. So I would say we had technology, engineering, art, math, because of Garo, which I'll talk about in a second. Science has to be in there somewhere. It's got to be in there, right?
Calculations. Yeah,
calculations, yeah, that's right. Yeah.
And a lot of luck.
That's right. Okay, so yeah, all of them, all the STEAM events. So we're just going to say that. Okay. So I got to take care of this. I don't even know what I'm doing up here. So this is how it started. I started up here, and as an artist, if you're applying for a bid or something like that, you just sketch and sketch and sketch and sketch until something finally pops out. So I did all these different, I knew I wanted it kinetic. And so I started just with these shapes moving around in the wind. This one's kind of cool. I think I'd like to actually make that one someday. But it didn't get the cut this time. And then all of a sudden, I think my wife said, why don't you make something with sails because it's Green Bay? I'm like, it's a great idea. So we went the sail route. And then, I don't know what this is. But it's on there. It came out somehow. Then the sail thing really took over. And eventually, we got to this, which is where we are now. It doesn't look entirely like that. This was still a sketch. This was my mind working on what would this look like kinetically. Because I could tell right here, but the exclamation point on this piece was its kinetic performance. This looks cool, but it doesn't knock your socks off. This over here, when it's moving around and you think it's going to fall on you, but then it doesn't, is awesome. That's part of art. It's got that tension in it. And Todd knows all about the tension now. So a successful piece of artwork puts tension into the viewer's mind. And this, I think, was successful in doing that. But I still didn't know what it looked like at the end. So this is a final rendering of what it looked like on the ground with uplighting and downward projecting lights. And that all didn't exactly pan out exactly the way it was conceived initially. But essentially, this whole piece stayed the same. And this was the final drawing that I went to find an engineer for. So I put together some very crude engineering. I mean, this is kind of cool. It's kind of three-dimensional, you know. We're getting some ideas down. I put that together too. This is an idea of what the axle assembly might look like. And I was just kind of shooting from the hip. I didn't really know what I was entirely doing. Some more sketching. So I went through all these sketching things and really realized I needed some help if I was going to pull this thing off. So I had these questions, and they came from the perspective that this was the largest piece I've ever done. It was public, so if you have a large public piece and you're just welding a bunch of axles and bearings together, there's some liability in there, but that's not good. It's not going to last forever. So I was considerate of that. It's also the most kinetic piece I've ever done. So those are two elements that were really driving this idea to invite some other people to the table to help this piece be successful. Specifically, those components were the axle bearing assembly, which on this piece there are 5 of, or 6. 1, 2, 3, thank you, Matt. 4, 5. So there's 5. And this one swivels around like this, and these were intended to nod back and forth. And so that's kind of a lot of kinetic infrastructure there that I didn't really know how to frame up inside the piece. And that's getting to the real beauty of this piece, I think, is the overall integrity. How are we going to make this work? When you look at it from the outside, you see one thing. But the inside is where all the thought of and engineering went into. So I didn't know how to do that. The foundation, like what I was going to put this on, in the past when I've installed sculptures, they've been a massive concrete pad, you walk away and it's fine. It's 100,000 pounds and you're good. This thing is going to require all kinds of stuff because there's a weight load on there, it's moving, it's like swiveling around. So I knew that there was a foundation issue. The materials, are we going to make this out of stainless? Are we going to make this out of aluminum? Mild steel? I didn't really know. So I needed help there. The hardware, the bearings themselves. Like I've bought bearings from Home Depot and those types of places, and they've worked out fine. And but this was going to take way bigger bearings that I didn't really know how to get those. And also the installation. How were we going to assemble the fin and sail based on the sketch that was projected? When I drew this thing, it was 23 feet tall, so that's kind of big. And so the calculation analysis, like how much wind can hit it, what temperature is going to be. What's that called when metal heats up and there's like expansion?
Thermal expansion.
That's it, thermal expansion. Thanks, Todd. So the thermal expansion, like there's calcs and analysis there that I've never had to do before. So I met a guy in Milwaukee who was an engineer, David Garrow. He does everything on paper and pencil, and he's not a CAD guy, he's an old-fashioned engineer, and he did all this mock-up calculation and analysis done, but he wasn't able to help design the piece. He helped us put together this foundation where we excavated and put in I think 23,000 pounds of concrete and rebar. So this thing isn't going, you could like put, that giant, like, Sheboygan has that big flag. You could put 3 of those on here and it would be fine in a tornado. So we're fine with the foundation, let me tell you. So, but I needed to get an engineer to help me design this thing, and I called 30 different places, 30 different firms, and I talked to 30 different people, sometimes more than that. I talked to 2 or 3 people before someone finally said no. So I couldn't find anybody to work with. And I thought it wouldn't be that hard. I never thought I'd have to call 30 different places. Finally, Infinity, where this guy works, stepped in. And the owner, Scott Santaga, who's not able to join us today, but he loved the idea from the get-go, and he committed resources to do this so that I didn't have to pay a dime for the engineering, which was ridiculously, would have been expensive. So thank you for those guys, yeah. And so Todd was called into the room, and would you say reluctantly you said yes to this, or?
Yeah.
Sure, yeah. Let's see, we're going to turn this on. Check, check. No, it's not on. Check. There we go.
I was scared. Having that much mass and weight twirling above people's heads is something that I've never done. I design machinery, safe machinery, close the door, stay away, you're okay. So when he mentions tension, yes, there was a lot of tension.
So this was an idea that was really kind of stretching both of our professional experience. So let's exit out of this and let's pull up. So now we're getting into the magic of this piece. And I know we're going to be coming close on time. Give it a click. There you go. There we go.
You want this?
Yep.
Okay.
So actually, yeah, hit that first file there. So everything that was made for this piece was made out of flat metal that was welded together in different degrees. So this right here is the spine for sail 1, which is that one right there. So that's the spine. And that was, I think that was half-inch aluminum. So this is all made out of aluminum, welded aluminum on the inside. Okay, go to that next file, Todd. And this was, so this is Todd's master. Well, I like to think this is, no, you've done some other stuff. This is my masterpiece. See, he made this, and I couldn't believe it. It was so beautiful, and it ended up being very, very strong. So this is what Todd made. This is what's on the inside of all those fins that are on Washington Street. These are all the rails and the spine, which you just saw is right back in there. And this is all welded together. This stuff right here is 3/4 inch aluminum, welded to 3/4 inch aluminum. So all those different gussets in there was all designed by Todd on a computer, and we're in this phase right now. This is probably the summer, and he's putting all this together. And can you play that? Yeah, play the next one. And you can see how all this is coming together. So, let's see, maybe I'll start again. Huh, why is it starting right there?
I don't know.
Let me see, I messed this up before. There we go. Okay, so you'll watch this thing kind of dissolve apart. This is essentially how I put together in the shop. And I did it in Jeff Benson's shop, which is right there. So thank you very much, Jeff, for letting me be in your space for like 5 years. I might have borrowed a few of your tools without asking. So this is how it goes together, just in reverse order. So this piece right here is composed of about 30 different pieces, and this entire piece together, all the bearings and everything, was probably like 400 different pieces. So let's see here. So this is Todd's what Todd contributed to the piece. All of this, and Todd, what was the hardest part of this piece, would you say, from your perspective as an engineer?
From my perspective, it was getting the sails to look like what you envisioned.
Mm-hmm.
So the mechanics for me were easy. The hard part was making it match what Kent wanted.
Yeah, and I was picky about it too. Yeah, so I gave him some pressure, and I gave him some tension. But ultimately, you can go ahead and click on the last one, Todd. So we made this. So this is what the piece looks like on the inside. I think it's just beautiful. Each fin or each sail is independent, and they're connected via these axle and shaft assemblies right here. Just like this right here. And we have the counterweights right here, because as you can see, the center of gravity looks like it should be up here, like these things should flip right on over, and that's intended to create that tension. In order to make it work, we needed to implement these counterweights on each of the sails, except for this one, sail 1, because it doesn't have that vertical rotation, it's just swivels. So this counterweight right here on sail 2, which is that one right here, has about 600 pounds of counterweight at the bottom, right there. It's all steel. It's all held in there, like really strong right into the chassis of this piece. So I think this is absolutely gorgeous. And we're going to try to make a 3-dimensional model of this small scale with actual bearings and shafts in there so that we can have it on a small scale. But this is the engineering component that's just way beyond me. So in order to create this artistic sculpture that I envisioned, I couldn't do it by myself. So this project is a true representation of cross-disciplinary efforts. Okay, so I know we got to keep going, so let's jump back to the, yeah, and that. And then present. Here we go. So this is how it came into the shop. We had it done laser cut. How much time do I got left, Matt? So I'm just going to really skip through this because I don't want to push back the other folks. Came in like this. That's one of the bearings, enormous. And we started fabbing it up. This is some pictures of it in fabrication process. This is the installation. This was an effort in its own self. And this is the final piece. And it's on Washington Street. If you haven't seen it yet, make sure you go when it's like 50-mile-per-hour gusts. And this is a video that ended up not working, so that's what that looks like. Talk to me afterward and I'll show you a video. But this is an effort that Todd and I both put a lot of effort into, and we come from different places. But in order for this to be successful, it needed both of our inputs, and we worked together, and we became friends. I like to call you a really close friend. Yeah, and it was just a great project all around, and I was so honored to work on it, and I just want to thank Todd so much for helping out. Thank you.
Awesome.
Let's just take a few questions, and if you want to talk to us afterward, I'm happy to talk. A few questions about this piece. Yes?
Just seeing the CAD/CAM drawings or the simulation, have you considered a work like this where you might leave it without the sheet, without the skin?
Yeah. And that's actually a great point, and that's why we're going to try to make a small maquette, probably a little bit smaller than that, that doesn't have the skins on it, just so you can kind of see it. But in order to make it like in an outdoor setting where it's getting wind, and we kind of needed some cover, but I don't know, what do you think?
I think covering it with like a polycarbonate or something, like a viewing window on one side would be pretty cool.
Get the best of both worlds there. Yeah?
Could you describe quickly the genesis of this project and how it was funded and why it was initiated?
Sure. So that's a great point. So some very forward-thinking people at the WPS Foundation put forth a grant for $100,000 that went to the city, $80,000 of which was for this one project. And so a bunch of people applied for it, and I was lucky enough to get it. And they wanted to put money to put a sculpture in Green Bay because they recognized what public art can do for our community, especially if their name is on it. I mean, it doesn't hurt. So now they have this giant bronze plaque that I haven't installed yet because it's like under 3 feet of ice. But when I do, it'll have their name on it. But that was WPS. They put forward all the money. But the actual sculpture itself was probably $150,000. We got 80 of it from WPS, and the rest was donated in kind by companies like Infinity.
I just want to say how beautiful, obviously, the exterior is, but I was surprised at how beautiful the engineering was.
Thank you.
That was just lovely. It's a work of art.
Yeah. Yeah.
Have you ever considered not passively agitating the system, but instead having some form of intended kinetic motion?
Like electrical or something, or even like person, like driven. Yeah, we were kind of talking about that.
Yeah, actually initially, to overcome all the center of mass problems that this project presented, our company deals a lot with servo motors, where we're making things move on purpose. That would have been much easier.
Project number 2, so if anybody's got $100,000 out there and they want to get this thing going, you come and talk to us. Okay, thank you everybody very much.